Carlisle manufactures comprehensive building envelope solutions from the ground up, including waterproofing, insulation, and single-ply roofing solutions. Carlisle's products play an important role to meet the increasing demands for improving the energy efficiency of a building. For this presentation, we will focus primarily on insulation. At Carlisle, our main insulation product is Polyiso. We also manufacture block-molded expanded polystyrene, or EPS, as well as spray foam insulation. These products are used throughout the entire building envelope, providing thermal protection in both commercial and residential applications. For our commercial roofing systems, we manufacture Polyiso insulation boards that have the highest R-value per inch in the industry. R-value is simply the measure of a material's resistance to heat flow. The higher the R-value, the higher the resistance and the better the material insulates. When thinking about reducing greenhouse gas, or GHG emissions, it's important to consider that building operations generate approximately 30% of the annual global greenhouse gas emissions. Commercial buildings use a lot of energy. The average office building owner or operator spends more than $30,000 per year on energy, and thus significant savings can be realized using additional insulation in the roof, walls, and floor. Electricity and natural gas account for over 90% of the total energy consumed in commercial buildings. When it comes to decarbonization, the most effective method of reducing CO2 emissions is to decrease the use of energy. Insulation's contribution to the roof system and throughout the building envelope does exactly that. Insulation keeps buildings warmer in the winter and cooler in the summer, allowing the heating and air conditioning units to run less frequently, so the desired interior temperature can be maintained. When a building uses less energy, non-renewable resources are saved, and GHG emissions are reduced. There is great and growing demand for upgrading the energy efficiency of commercial buildings in North America. First, there's the re-roofing cycle in the US. Second, the push for greater energy efficiency of buildings. And third, new construction demand and designs to meet zero net carbon standards. Buildings constructed 10 to 20 years ago make up approximately 25% of the current base of commercial buildings in the US. This is what's setting up a very healthy re-roofing cycle in the US for the next decade. To meet emissions reduction targets set by the Paris Agreement, there will need to be a significant improvement in the energy efficiency of existing buildings. This contributes to an even higher demand for energy-efficient upgrades going forward. It is estimated that 2.5 trillion square feet of new floor area will be added to the global building stock by 2060. That equates to more than a doubling of the commercial building floor area over the next 40 years. These new buildings will need to be designed to meet zero net carbon standards. An energy-efficient roof system with the highest R-value available should be on any architect's or building owner's shortlist of energy efficiency solutions. Primary energy demand, or PED, quite simply describes the energy associated with manufacturing a product compared to the energy the product saves over its lifespan. In the US, the national average ratio of energy savings of Polyiso is 28 times greater than the energy used to produce it. The time it takes to recoup that energy used to produce the insulation is only 15 months. In the colder climate of Canada, the ratio is 38 times, and the energy used to manufacture the products is recouped in only 12 months. Looking at this another way, additional insulation installed during roof replacement contributes to the avoidance of emissions associated with building operations. Global warming potential can simply be described as the comparison of the amount of CO2 utilized in manufacturing the product versus the amount of CO2 which is then avoided over the life of the product. Polyiso's insulations ratios are very compelling, as the national averages for both the US and Canada exhibit substantial environmental benefits in terms of greenhouse gas emission reductions. The US national average for the CO2 avoidance ratio is 34 times. The average CO2 recoup period is only 13 months. In Canada, the emissions prevented is even greater, providing 45 times CO2 avoidance, offsetting the amount generated in the first 9 months of the roof installation. Next, you can see the practical impact of these increased insulation code requirements. In the example, we are showing the impact of moving from an R20 to an R30 minimum insulation requirement in climate zones 4 through 6. The majority of the population in the US lives in these climate zones. I want to further explore the energy savings associated with using additional code-required insulation amounts on the roof. In Minneapolis, located in climate zone 6, we see savings of just over $140,000 with a 6-year payback period. In Dallas, located in climate zone 3, we see savings of $70,000 with a 10-year payback period. Again, the insulation investment of the additional R10 into our example building came at a cost of $31,000. Building owners typically replace and upgrade their roofs every 15 to 20 years, which is an opportune time to increase the insulation amount in a roof system and thus upgrade the energy efficiency of the whole building. We're starting to see these increased insulation amounts being utilized in our commercial roof systems. The chart shows the insulation board foot to membrane square foot ratio for the years 2013 through 2019. As you can see, membrane has grown 6.3% annually, on average, whereas insulation has grown an average of 10.2%. This represents a 1.6 times increase of insulation usage to membrane usage over the last 6 years. Next, we highlight some design considerations. Insulation provides the best long-term return on investment based on the improved energy efficiency. As Carlisle is the leading supplier of both darker EPDM roofs as well as reflective white roofs, we've sometimes been asked about the impact of roof color on energy efficiency. Roof color does have an impact on energy efficiency, but it is very dependent on location. We find that white roofs in southern climates can reduce energy consumption by reducing surface temperatures of the roof. A roof type that is emerging in the US that provides the most sustainable solution is a roof garden. A roof garden goes far beyond that basic sheltering purpose of a roof to provide a solution that can enhance the building's performance as well as the utility of the roof area. Carlisle supplies all the components of the roof system, roof garden, and the hardscapes. As we look towards construction applications that really enhance sustainability of the environment, roof gardens are a standout for not only their extended life cycle, but also other positive impacts on the environment.